What's good, y'all? It's Jeff. In this video, we're going to talk about MATLAB's built-in functions. We've seen previously how to use MATLAB to do arithmetic operations using plus, minus, times, but MATLAB can do a whole lot more than that using something called a function. Now, for you math heads out there, you've probably heard that word function. I'm out here trying to function in the context of a math class. Here, we're talking about the word function from the standpoint of programming. Before we dive into the differences between what those are, I want to introduce some language that is useful in this context. To do so, let's go to our favorite search browser and type in operator overloading. This is a formal word in computer science. And then there should be a Wikipedia article. Let's go ahead and click on that. Notice that there's some information here, some crazy stuff. One of the things that you'll see over and over and over again is I'm going to teach you how to teach yourself. My job as a teacher is to make myself useless. One skill that's super useful in learning how to program is trying to understand the technical language of computer science. Let's look at this first sentence, which is a doozy of a sentence. In computer programming, operator overloading, sometimes called ad hoc polymorphism, is a specific case of polymorphism where different operators have different implementation depending on their arguments. Blah, 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 blah. Who talks like that? What they mean is that one typed symbol from your keyboard can do different things depending on how you type it. We're going to take a look at that in just a second in MATLAB, but I wanted to go down here to the rationale because there's something that makes me smile and might make you smile too. So whoever's writing this says operator overloading is syntactic sugar used because it allows programming using notation near the target domain. So first of all, I want you to kind of laugh right here. Syntactic sugar is syntax, computer programming symbols that are used to program, that makes it sweeter for the end user. I mean, these nerds, you got to give it to them, man. They use really nerdy stuff and then normal stuff and they bring them together. The basic idea here is that when we're typing programming symbols into a computer, the symbols have meaning that is going to be executed by our language. So for example, in MATLAB, the plus sign has meaning. If I put +4, that's what we call a unary positive because it expects one input, it expects one number, and on the left it's saying, I want this to be interpreted as a positive number. That symbol, if I use it in a different context, so 4 plus 7, that is now a binary operator. It's not a unary operator. Unary means it takes one input. This is unary because the unary plus sign is taking a single input on the right-hand side. The binary plus sign is taking two inputs, binary, two inputs, one on the left and one on the right. When I hit enter, it will produce a different output than it did up here. These single symbols, the symbol of hope in the city of Gotham, the plus sign is being used in different scenarios, even though it's the same symbol. So we call that in computer science or programming an overloaded operator, because the same operation, the same symbol, is used in two different contexts. Notice in this situation that I can't put a plus on the right-hand side of a number. That's actually an error, and that's because that operator is not defined for having a left argument. So even though it's an overloaded operator, it's used for different purposes, even though it's the same sign. It does have special syntax requirements, special ways that we type it. The reason that this is useful is that the word function is overloaded in MATLAB. What I mean is when we're using MATLAB, we have actually two different brains. We have the brain of a mathematician, aka somebody that's thinking about a function as a relationship between sets. And we have the brain of a computer scientist where we're thinking about a function as the implementation of some computer code to output a calculated value that gives some representation of a mathematical idea. Blah, 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 blah. What am I trying to say? When we're using the word function in MATLAB, what we mean is a set of typed symbols that calculate something we want to know about. After that nerdy diversion, let's go back up to the Resources tab and learn more about elementary built-in functions in MATLAB. Click on Resources. Let's go down to the Help button. And then in this case, instead of doing documentation internally in MATLAB, let's try the support website. Much of the documentation available through MATLAB is also available online. This is an example of that. If we go to mathworks.com/support, we can see a bunch of different options. In this case, we're going to go ahead and click on the documentation button. That brings up a long list of documentation. Let's start with MATLAB, since that's what we're learning in this case. Then let's go down to the mathematics link and then click on elementary math. Notice that there is a lot of information about arithmetic operations, trigonometry, exponents and logarithms, complex numbers, discrete math. Let's type exponents and logarithms. Let's go ahead and click on that. These are now functions in MATLAB. This gives us a list of functions that MATLAB provides for us. So say, for example, that I wanted to take the square root of a number in MATLAB. Question, how could I do that? Well, we see that exponents, square roots is like some number to a 1/2 power. That's kind of an exponent or a power. There are two different square roots here. If we were to read the description of what these functions do, there's something called square root and real square root. We're not sure which one's which. Let's go ahead and start with real square root first. So real square root takes the square root for a non-negative real array. The syntax for that, the way that we type it into the command window, looks something like this. Left-hand side is a variable y, assignment operator, and then we type in real square root of x. In this case, we're looking at the description. Y equals real square root of x returns the square root of each element of an array x. What the hell does that mean? The size of y is the same as the size of x. This gets into a larger discussion about MATLAB being an array-based language. We're going to defer that to our next lesson. But for now, let's go ahead and see how we could use the real square root function in MATLAB. Specifically, let's go ahead and find the real square root of the number 4. Notice that when I did this, I was entering this set of symbols, open parentheses, close parentheses, and then the input to that function is 4. And MATLAB is saying the square root of 4 I'm calculating as 2. I could also take the real square root of perhaps 16. Let's go ahead and look at what that looks like. Guess would be 4. Lo and behold, I produce 4 out. Let's take a deeper dive into the syntax, the way we type this command in the MATLAB command window. Notice there are a few different features of functions, built-in functions, that are worth mentioning. First, every function has a name defined by MATLAB. So the name of this function is called the real square root function, and the way that we type it is REAL, no space, SQ as in square, no space, RT. That function name tells MATLAB to do some calculations internally. Every built-in function in MATLAB is going to start with a lowercase letter. We'll talk more about that later. When we define our own functions, I'm going to recommend that we do a uppercase letter to distinguish between what we call built-in functions versus user-defined functions, functions that we write. That's a kind of a trick that we can use to immediately know, hey, this is something that I wrote. Oh, that function over there is something that MATLAB is writing. After we have the function name, with no space between, we're going to write an open parentheses or a left parentheses. Then inside, we're going to write a function argument or an input. So we're going to tell this function, this operation, to act on some number. And then we're going to finish that command with a right parentheses or a close parentheses. Let's see that again in action. Suppose that I wanted to take the real square root of the number 3. Notice that in my case, I'm using that trick we talked about in a previous video. The moment I do an open parentheses, I also immediately do a close parentheses, and then I go back inside those braces to type the input. Here I have my function name, followed by the open parentheses, the input or argument to my function, and the close parentheses, and then I can push enter. Let's take a look at some other elementary functions that are built into MATLAB. Perhaps we're interested in learning how to take the nth root of a number. So here the function nth root, let's go ahead and read about it. Notice that the syntax follows that pattern. Left-hand side is a variable, the assignment operator, and then we have the name of the function. In this case, it's called the nth root function. We have an open parentheses, and in this case, it's telling me I need 2 inputs. The first input is the number that I'm going to take the nth root of. The second index is the value of n that I'm trying to find the nth root of. Here we see that we have an example of what this looks like. So if I take the nth root of negative 27, where the value of n is 3, MATLAB should output answer, the output of that function call is negative 3. Let's go ahead and test that on our computer. So nth root function, then I'm going to open and close parentheses. We tried negative 27 and 3. When we push enter, indeed, MATLAB takes negative 27 to the 1/3 power, or the third root of negative 27. Let's try another example with this. Let's take the nth root of negative 64, and in this case, we'll define n to be 6. When we put enter, notice that I just broke that function because it's saying I cannot take the 6th root of negative 64. That doesn't give me a real output. But if I did the nth root of 64, where n is 6, so the 6th root of 64, indeed, 2 to the 6th is 64. I'm going to make a claim that all of these functions that we see here, and indeed, if I were to go one level up, I could go back to the elementary math page on the documentation. Let's take a look at trigonometry. Here are a bunch of different trigonometric functions that I can use in MATLAB. So for example, sine has a bunch of different versions. It has sine where the argument is in radians. It has sine where the argument's in degrees, and that's called SIND. Computes sine of x times pi, inverse sine in degrees, hyperbolic sine, etc. Let's take a look at sine d. What we see is that this is the sine where the argument, the input to the function, is in degrees. Here's an example. If I put sine d of 180, the claim is, what is the height of a point on the unit circle that is 180 degrees away from the initial array? Well, it must be 0. That's the claim of that. Let's go ahead and test that in our MATLAB command window. So if I type in sine d of 180, claim MATLAB produces 0. Notice that in all of these situations, we're finding a pattern. When we call built-in functions in MATLAB, we have the function name, open parentheses, argument or input to the function, close parentheses. To make that really explicit, the syntax for built-in MATLAB functions, syntax is just a formal way of saying how we type in that input, how we tell the computer, I want you to do something very specific. What are the symbols that we input to the computer in order to get it to jump to our command? In this case, when we're using a built-in function, there will be a pattern in all the different functions we used, and it looks like this. We're going to start with what we call a function name. That's a predefined set of symbols that the MATLAB coders used when they were writing the MATLAB itself. All predefined functions are going to start with a lowercase letter if it's a built-in function in MATLAB. I always encourage my students, when you're writing your own functions, let the first letter be uppercase so that you know that you wrote that and that's not native to MATLAB. It's not built into MATLAB. After we write the function name, we're going to, no space, use a left parentheses or an open parentheses. Then, if you're typing the way that I would suggest, immediately do a close parentheses, bring your cursor back inside of that, and then type the argument inside the function. Every time we call a MATLAB function, we're going to use this pattern. I want to make 2 notes here. The first note is that sometimes we can actually store the output of a function as a variable. So let's say that I wanted to say that x is the real square root of 4. In other words, x is 2 because x squared is 4. Notice that I am actually saving the output of the real square root as a variable value. It's kind of a useful thing to realize. And when you look at the documentation, so another way to get to the documentation for a function is actually just type in help and then real square root. And this will give me an overview of how real square root is used, gives me a description, and then also gives me some references. I can then look at the documentation, which will pull up the page associated with that function. Notice in that page, when I'm looking at the general syntax suggested by the MATLAB documentation team, they're actually saying, this is how we call the function and suggesting that we should save the output as a variable. The other thing that I wanted to note was that MATLAB, as we've discussed before, is really designed for scientific computation. And there are a ton, I'm talking about like a whole heap of built-in elementary math functions that require no special packages per se. This contrast with general purpose language like C, C++, Python, etc. Often if we're using those general purpose programming languages for mathematical applications, we may need to import special libraries just to have access to routines that do calculations for us. In contrast, MATLAB is designed to allow us to do scientific computation, mathematical modeling very, very quickly. And because of that, many of those functions that we would use in mathematics are built into the MATLAB environment. And all I have to know is what's the name of the function and how to use it. We've just seen how we can use the documentation to kind of search different functions that MATLAB provides for us. Those are called native MATLAB functions or built-in functions on the MATLAB platform. Let's keep going with our discussion of how we use functions. We'll go ahead and clear our screen real quick. One of the things that's really interesting about functions is that many different types of calls can be made. When I use a function and tell MATLAB to calculate something, that's called a call to the function, or we're using the function to do some calculation. One way we can use a function is to input a number inside the argument. So in this case, this is just a representation of a scalar, and then I can get that output. But I can also input variable values. So pretend for a second that I said x is 64, and then I take the real square root of x. Notice MATLAB is going to take the stored value of x and then calculate what the real square root of that using that function. Here's another thing that's really interesting. Let's go back to the previous command that I just ran by pushing the up arrow. That scrolls through my command history from the most recent command backwards. In this case, I can actually do an actual calculatable expression inside the function input. So specifically 4 times 9 plus x, MATLAB has to do some work inside the argument before it gets what I'm going to take the output of. Notice that 4 times 9 is 36, x is 64, 36 plus 64 is 100. We would expect that the real square root of 100 is 10, but I'm not actually doing the output of that calculation. I'm putting that expression inside the argument, and yet MATLAB still produces the output. Another thing that's really interesting is I can actually do functions inside of functions. So let's remember that the real square root of 100 is 10. If I multiply 10 by 9, so 9 times 10 is 90, and then let's add 54 to that 90. So 54 plus 90, well, that must be looking something like 144. Notice that I'm actually calling inside the real square root function another real square root function, which is really kind of interesting. When I push enter, what's the square root of 144? Must be 12. So I can actually input inside the argument the output of another function. Another example of this is let's try sine d of 180. Remember we said that that was 0 previously in this video. What if I were to take the sine of sine d of 180? So sine d of 180 is in output 0. What is the sine of 0? Well, my guess is it's 0. Which is exactly what we see. In other words, I can use the output of one function as the input of another function with some special consideration having to do with data type. With that, we're going to conclude our introduction to using built-in or native MATLAB functions. I do want to say one last thing. If I go to the documentation search bar on the top right-hand side of our MATLAB desktop and I type in elementary math, that will get me at the top result. If I click on that, that gets me back to the list of functions. Then I can click on the appropriate link. So let's say discrete math. Check this out. There's a factorial. So I'm guessing that if I type in factorial, let's do 5 factorial, and boom, check it out. 5 factorial is 1 times 2 times 3 times 4 times 5. That is indeed 120. In other words, a great way to figure out what are the names of functions that you can use to do calculations in MATLAB is to actually read through that documentation. Another way to do that is to actually open your search browser and just type in a query. So suppose I wanted to say, how do I calculate e to the x in MATLAB. And then what's going to happen is, well, looks like they have how to use the constant e, how to plot e to the x, how to calculate a value. Yeah, let's go to the first one. Let's say exponentials in MATLAB. Notice that that brings me back to the help center of the documentation, and it actually says exponent of x. Now all of a sudden I have an example of how that works out. I have some code. I could have done the same thing if I would have typed up in the documentation search bar exponent. That would lead me to that top one. So I can kind of combine the sources of help to find answers to the questions that I have. This is actually a deliverable in my course. It's something that you're going to hear me talk about a lot. I want you to learn how to teach yourself this programming language. It's a very, very powerful skill. And at this time, we have so many resources, including MATLAB documentation and search browsers for the internet. We'll talk more about that in future lessons. For now, peace.